everyone. As you know that I am doing fluid mechanics previous year questions uh, for mechanical engineering and as well as for the civil engineering students. Okay. Uh, Today I am going to start a new topic that is nothing but buoyancy and flotation. So these so from this topic I will deal with the engineering services questions. Okay, this is about myself. I have already completed almost 14 lectures from the topics like properties of fluid and hydrostatic forces. So if you are new in this channel, please watch those videos as well. It will really help you. Okay, so let's see the questions of buoyancy and flotation. This will be the part 1. So there will be another part as well. Okay, let's see that. Okay, so the first question, what is the buoyancy force? Okay, so let's see the options. A lateral force acting on the submerged body, resultant force acting on submerged body, resultant force acting on submerged body, resultant hydrostatic force on body due to fluid surrounding it. Okay, so it is actually it is not a resultant force. Okay, it is not a resultant force, so B and C will not be there. So the lateral force acting on submerged body, this also be wrong. It is actually resultant force on the body due to fluid surrounding it. Okay, so answer is D. Okay, let's read the explanation. When a body is either fully or partially submerged in a fluid, a lift is generated due to the net vertical component of hydrostatic pressure force experienced by the body. Okay, this lift is called buoyancy force and the phenomenon is called buoyancy. Okay, so anything is floating is due to buoyancy only. Okay, because its weight is actually equal to fluid weight of the fluid displaced. Okay, that is actually nothing but buoyancy phenomena. Next question, it's assertion reason question. Let's read that the buoyancy force for a floating body passes through the centroid of the displaced volume. Okay, reason the force of buoyancy is vertical force and equal to the weight of the fluid displaced. Okay. Explanation. Okay, see, assertion, the buoyancy force for a floating body passes through the centroid of the displaced volume. Yes, this is absolutely true. And the force, the reason is the force of buoyancy is vertical force and equal to the weight of fluid displaced. This is actually the definition of buoyancy itself. Okay, and this reason is also correct explanation of assertion. So its answer is A. Okay, so like we'll read this. When a solid body is either fully or partially immersed in a fluid, the hydrostatic lift due to the net vertical component of the hydrostatic pressure force experienced by the body is called buoyancy force. The buoyancy force on the submerged or floating body is equal to the weight of liquid displaced by the body and acts vertically upward through a centroid of displaced volume known as center of buoyancy. Okay, so this is the expression, you can see that, which is this is not recorded. Anyway, we'll read that. Which is the centroid of the displaced volume. This is actually the centroid of displaced volume. It is due to the buoyancy. The force is equal to the weight of the fluid displaced by the submerged body of volume. The force of buoyancy is vertical force. Okay, the x coordinate of the center of the buoyancy is known as is represented as this expression, which is the centroid of the displaced volume. Okay, so this explanation is not much important. Okay, so you just know that buoyancy is nothing but it is the the weight of fluid displaced. That is nothing but it is like weight of the weight of the body. So that is like buoyancy phenomena. It's like it is the buoyancy force or buoyancy, you can say that. Okay, that is the thing. So its answer is A. Next question, which of the following is the condition? Which of the following is the condition for stable equilibrium for a floating body? Okay, so anyway, see, I am not giving much explanation in these questions, but to know more about these concepts, uh, I will come up with the complete lecture series of fluid mechanics. So there we'll see these concept very extensively. So if you'll watch those videos, so it will be very helpful for you. Okay, and these questions you can easily solve them later. Anyway, let's see the option. The meta center coincide with the center of gravity. The meta center is below the center of gravity. The meta center is above the center of gravity. The center of buoyancy is below the center of gravity. So actually, whenever this, see, the floating body concept will come into picture. Just you just focus on meta center. Okay? So it is actually, see, the meta center is above the center of gravity. So the answer is C. Next question, the resultant pressure of the liquid in case of immersed body acts through which one of the following? Center of gravity, center of pressure, meta center, center of buoyancy. So this is actually P, center of pressure. So for submerged body, it acts through the center of buoyancy. Next question, assertion reason. Okay, if a boat built with a sheet metal on wooden frame has an average density which is greater than that of water, then the boat can float in water with its hollow face upward but sink once it overturned. Okay, reason buoyant force always act in the upward direction. So this is actually, see, both the statement is correct. Okay, so if a body built of with sheet metal on a wooden frame has an average density which is greater than that of water, then the boat can float in water with its hollow face upward but will sink once it overturns. Yes, this is correct. Okay, and buoyant force always act upward direction. Yes, this is also correct. But see, this, like, sink once it overturns is not related to this buoyant force. So that's why this is not the correct explanation. So the answer is B. Okay, so we'll see that. Okay, location of meta center and center of buoyancy decide the flotation of body. Okay, so with not buoyant force we cannot say anything with the location of meta center. Okay, so it is like they are talking about stability and instability. Okay, so if, like, meta center above and below, based on that we have to tell about whether it is sink or not. If it is like unstable equilibrium, then it will overturn. Next question, which one of the following statement is true? Okay, so we have to read that. For an ideal fluid, mu is equal to 0, rho is constant, k is equal to 0. A floating body is in stable, unstable or neutral equilibrium according to as the metacentric height is 0, positive, negative. The exact analysis of viscous flow problem can be made by Euler's equation. The most economical diameter of the pipe is the one which the annual fixed cost and the annual power cost to overcome friction are minimum. Okay, anyway, we are dealing here the buoyancy and flotation. So you can, according to that, you can easily answer this question. But actually, if this question is directly coming in the exam, then it is like difficult to decide out of 4. Answer will be, okay, so actually this is this statement is actually wrong. The first is wrong. Okay, for an ideal fluid, mu is equal to 0, rho is equal to constant, k is equal to 0. This is also wrong, and this is also wrong. Okay, stable, unstable, and neutral. So I mean, it should not be, for stable it should not be 0. It should be actually positive. Okay, So this is wrong, and the exact analysis of viscous force problem can be made by not by Euler's equation. Okay, it's not by Euler's equation. It is by actually Reynolds number, Reynolds equation. Okay, and the most economical diameter of pipe is one for which the annual fixed cost, annual power cost overcome the friction or minimum. Yes, D is correct. Okay, so yeah, this actually here they are saying a Navier-Stokes equation. Anyway, in Navier-Stokes also the Reynolds number come into picture. Okay, so anyway, it's not not Euler's equation. It is actually Navier-Stokes equation. Okay, so actually Navier-Stokes will contain most of number like Prandtl number and Reynolds number. So even the viscous flow is coming there in your mind. The Reynolds number should click in your mind. Okay, this is the thing. Next question. Hydrometer weight of 0.03 Newton has a system at the upper end which is cylindrical and 3 mm in diameter. It will float deeper in oil, specific gravity this, then the alcohol of specific gravity this, how much amount. Okay, anyway, okay, see, we know that what is volume. Okay, so we know the volume, it is weight by density into G. This is for oil, this is for alcohol. Okay, just subtract these two. So if you subtract, you will get this. Okay, so volume is given and density is given. So volume is what is actually pi by 4 d square into h, that is the volume. Okay, so they are asking actually h. Okay, so W is given, G is given, rho is given, rho oil is given, rho alcohol is given. Just put here, solve for h. So you'll get 36 mm. So the answer is D. Okay, you just use these expression for solving this question. You will easily get the answer. Next question. Body weight is 30 Newton and 15 Newton. 30 Newton and 15 Newton. When weighed under submerged condition in liquid of relative density this respectively, what is the volume of the body? So actually this question is a little bit complicated. We will see that. Okay, so see, actually body weights. Okay, इसमें देखिए what we have to do. Actually we have to do the weight balance. Okay, so like suppose this is the first body. Okay, so like let's say it's W. Okay, so like there is, you can say like there is tension, so here the buoyancy force will act. Okay, this is B. This equation we have to use actually. Okay, so W minus this is equal to this. Okay, so for 30 Newton we have to use this is actually V rho G. So for first fluid it is rho V rho 1 G. So you can see this one. So W minus V rho G is equal to 30, and similarly for 15, like W is equal to V rho 2, G is equal to 15. So this is equation 1. Equation 2. Okay, just divide these two. Okay, then you will get relation between V, W and V. And now just this V put in any of the equation, either this and either this. Oh, okay, so then you can solve for V. Okay, you can solve for V. So V will be it will be 3.82 liters. So it is actually B. It is actually it's like saying D. No, this is actually B. The answer will be B. It's not D. Okay, so you have to use this equation. Understood? So yeah. Next question. If B is the center of buoyancy, G is the center of gravity, and M is the meta center of floating body, the body will be in stable equilibrium if mg is equal to 0, m is below g, bg is equal to 0, and m is above g. So they are actually asking about stability. It is actually D when m is above g. So for a stable equilibrium, just remember meta center should be above center of gravity. For unstable equilibrium, meta center below G, and for your neutral equilibrium, it should coincide. M and G should coincide. Okay, so yeah, this is the end of like few questions from buoyancy and flotation. It is not the end. Okay, I will come up with the more questions from the buoyancy and flotation. This topic actually very important, even for the gate point of view, for the engineering services point of view, or in any of the exam where mechanical engineering, I mean fluid is the one of the subject. So you will find question from this topic, because this is like very conceptual and very important. Okay, thank you for watching. Bye bye.